It was an honored second when the Andromeda Cloud, for the present, transformed into the Andromeda Infinite Framework. The James Webb Telescope has perceived 6 universes that exist a portion of 1 billion years after the tremendous blast. This is incredible when you really look at the night sky, making the rounds a pinpoint of light. At the point when broadened, it gives you one of these photographs from the Webb Space Telescope. It was an honored moment as the Andromeda Cloud changed into the Andromeda World. For a long time prior, our cognizance of the Andromeda World was confined to base discernments. In any case, with advancements in technology and the presentation of the James Webb Space Telescope, our perception has grown tremendously. Now, things are going to change as the James Webb Space Telescope has recognized upsetting signs coming from the Andromeda universe. These signs have sent shockwaves through the academic community, leaving stargazers both inspired and curious. But what exactly do these signs mean, and why are they causing such a commotion among space specialists? Join us as just 2 minutes earlier, the James Webb Telescope shut down right after receiving upsetting signs from the Andromeda Vast Framework. Previously, we could see far beyond our eyes into the universe. Cosmologists trusted the Milky Way for being the whole universe. This shortfall of information was fundamentally because of limited advancement for seeing different inestimable frameworks and individual stars. At any rate, everything changed when we found the Andromeda World. It filled in as our most critical sign that the universe extends far beyond the Milky Way. In the 17th century, Galileo Galilei's initiating work with telescopes revealed the Milky Way's undeniable nature. He saw that the Milky Way had different stars, testing the winning idea of its specific meaning. Everything changed in the 1920s when Edwin Hubble saw distant objects beyond the Milky Way using the Hubble telescope. Edwin observed that these brilliant objects traveling through the universe were universes, not exactly the same as the Milky Way. One of the frameworks was the Andromeda World, or M31. While this was the point at which we first saw the Andromeda World through a telescope, Persian cosmologist Abd al-Rahman al-Sufi first noted it around the 10th century on record of mechanical types of progress. In the 20th century, space specialists could see and sort out the genuine substance and exemplification of Andromeda. It is an indistinct cloud involving a gigantic universe of stars, much like our Milky Way. Our boundless neighbor is around 2.5 million light-years from the Milky Way. Since its discovery, the way we focus on Andromeda has altogether progressed. We have moved from ground-based discernments through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Every movement in development has taken us higher than at any other time, helping us understand the secrets of the Andromeda universe. We currently have more information and insight into its creation and structure, making Andromeda a benchmark for considering the development of universes. This has uncovered more understanding into the greater working norms of the universe. Scientists believe that to have a better perception of our universe and the Milky Way, we ought to focus on the relationship between Andromeda and the Milky Way. This is especially true, given that the two frameworks will undoubtedly crash in around 4 billion years. While studies and assessments have progressed, the James Webb Telescope has recently gotten an upsetting sign from Andromeda. This upsetting sign confuses scientists, generally actuating questions with respect to its cautious starting and possible implications. The James Webb Telescope's high-level sensors have recognized extraordinary development right inside Andromeda's community. The sign sent back to analysts shows results that contrast through and through from past discernments, dazzling scientists in general. The sign illustrates huge cycles happening inside the world, potentially associated with its truly enormous black hole or previously concealed events. Strikingly, one of the latest discoveries illustrates that Andromeda's mass may be a lot greater than that of the Milky Way, reshaping how we could interpret both infinite frameworks. The James Webb Telescope has moreover given detailed pictures and spectra of Andromeda, revealing the development of new stars and their compound designs. This new data is critical for understanding galactic development and the conditions for life. Additionally, the data from the telescope suggests extended development in Andromeda's dynamic vast center. This has, in the end, impacted its surrounding environment and is expected to shape its future development. Other than by examining the gravitational effects on stars inside Andromeda, trained professionals gain bits of insight into the scattering of confusing dark matter all through the vast framework. Ideally, this helps our understanding of its effect on the components at play in the universe. Sorting out dark matter and its impact on the universe is one of astronomy's most conspicuous questions. Late forward jumps by the James Webb Telescope have motivated various investigations as analysts examine the insider realities of Andromeda. With more information becoming realized, we now find out about the framework, both past and future. So, what have we learned about the Andromeda world through various examinations? Andromeda has shown vital characteristics that separate it from various universes spread across the universe. Its sheer size commands thought, with late assessments suggesting an expansiveness crossing around 220,000 light-years. This figure makes it one of the greatest galactic frameworks in the local group, much more significant than the Milky Way. This enormous extension adds to its mass, containing a normal trillion stars, beating our vast framework in star count. Research also sees the framework structure as charming. Not like an ordinary winding framework, Andromeda has an expanding center and a thick center, encased inside rings of dust and gas. This is without a doubt a rich ground for persistent star development. Such features show a dynamic universe made by steady processes forming its advancement. Among its numerous components, one of specific interest is its center. It is described by a twofold zenith release, demonstrating the presence of a supermassive black hole, but not exactly equivalent to the Milky Ways. This offers huge insights into the nature and activities of these huge matter-eating openings. The Andromeda world is similarly encircled by a circle of sublime trash, including stars, planetary, and globular gatherings crossing numerous enormous quantities of light-years in expansiveness. This tremendous covering tells a captivated, organized story of the world's intriguing start and history. The 460 globular gatherings tracked down in Andromeda likewise offer information into the plan of stars in their first stages, giving a clear explanation of the development of star gatherings and the early new development of the universe. In figuring out the secrets of Andromeda, stargazers are the slightest bit closer to understanding the tremendous relevance of dark matter. At any rate, one request holds up. How do they represent its bewildering nature and the work it plays in the components of vast frameworks? Andromeda boasts another undeniable feature: its satellite universes. Its crown structure is contained in excess of 20 smaller infinite frameworks, and some of them are going through streaming, denying their stars and gas. This cycle involves a greater astronomical framework pulling in and destroying bordering minimal astronomical frameworks. This shows the dynamic nature of huge development and describes how universes create and connect with one another over an extended time. So, what does the future hold for the Andromeda framework? The shape and direction of its development entrance cosmologists, as well as those attempting to fathom the universe. The possibility of its encouraging from a twisting to a ring universe is partly essential in Andromeda's progression. Verification centers on a collaboration that could brief other captivating mixes, maybe from grandiose effects or close relationships with various universes. If Andromeda truly is pushing toward this way, it suggests that it has experienced various associations with other astronomical frameworks since its first encounter with the world. Eventually, Andromeda's future depends upon the unpreventable accident with the Milky Way, as demonstrated by these models. The effect is estimated to primarily happen 4 billion years from now. The result of such an effect is the formation of a new world from these two giant stellar entities. Anyway, it is a part of inestimable advancement. At any rate, due to the gigantic distances between the universes, this infinite crash is certainly not an immediate quick impact. After the effect, the two infinite frameworks would be significantly modified, outlining new shapes and associations. The correspondence of their gases and dust will work up new rounds of star creation, inciting a colossal presentation above as the mixing objects shimmer brilliantly. Eventually, such a boundless event will result in the development of a lone round universe. This kind of effect is not uncommon, as the universe has a long history of such events. At any rate, our immediate interest makes it an event essential to us. Additionally, the expected crash of the exceptionally colossal black holes at the center of the two universes adds more complexity to the radiant show. This suggests a perplexing and significant nature of tremendous advancement. The union is expected to convey impacts for the issue being immersed by the black hole, which will convey wide radiation. This association offers significant data about how vast frameworks move throughout their life cycle and how black holes impact this development. In any case, it raises a crucial issue. What will happen to our close-by planetary group after this combination is formed? Off by a long shot to a total obliteration of the nearby planetary group, the close-by planetary group's heading and conditions could be changed substantially. This suggests possible orbit shifts or even launch from the newly emerged vast framework. To handle this mechanism, scientists can concentrate on the scale of similar events happening and contextualize the possible fate of our own universe. It is significant to fathom that an accident between stars is an extraordinary event in space due to the enormous intergalactic distances. In any case, the gravitational change could agitate stars' stable orbits, causing a few stars, including our Sun, to head in a different direction. Such a change could substantially affect the climate on Earth. Maybe one of the most essential changes people could experience is creating some distance from or closer to the Sun. This could prompt one or the other warming or cooling influences. A hotter climate could make ice caps liquefy and sea levels rise, while a colder one would ignite another ice age. On top of that, the estimation of such a plan could block radiation levels from reaching Earth, making significantly more challenging conditions. The Milky Way and Andromeda galactic frameworks are destined for a close-to-home effect, an event that will reshape the endless scene. This impact, estimated to occur in around 4 billion years, will be perhaps one of the most critical events in the universe's plan. As the two universes wind toward each other, their common gravitational attraction will begin a stunning dance of immense powers. The accident isn't a direct impact, but a consistent mixing process. During this cycle, the astronomical centers will eventually merge, provoking the development of a new combined vast framework. In the early periods of the accident, communications between the galactic plans will set off an extraordinary star formation. The gravitational agitating effect will pack interstellar gas and dust, lighting new star births. This starburst development will make an explosive show of radiant fireworks, with newborn stars illuminating the merging universes as the Andromeda and Milky Way galaxies continue their inevitable path toward collision. There is much to consider regarding the aftermath of such a monumental event. This future cosmic merger is not merely a blending of stars, gas, and dust. It will also present profound implications for the formation of new celestial structures. The impact will create a dynamic environment where star formation rates will surge, leading to an extraordinary burst of activity as the gravitational forces at play pull matter together. This stellar genesis will be accompanied by waves of radiation as new stars begin to shine brightly in the wake of the merging process. Beyond the visual spectacle, the collision will also have a significant influence on the interstellar medium of both galaxies. The gas clouds and dust particles that populate the space between stars will be compressed, igniting new star systems and creating an entirely new structure in the resulting galaxy. The swirling, chaotic forces at play will also stir up previously unseen phenomena, potentially revealing aspects of dark matter that remain hidden in the current state of observation. The insights gained from such an event could shed light on how dark matter contributes to the formation and structure of galaxies. As the Milky Way and Andromeda collide, their supermassive black holes at the centers of both galaxies will inevitably come into closer proximity. These black holes, which are millions or even billions of times the mass of our Sun, will eventually merge themselves, producing powerful gravitational waves. These waves, ripples in the fabric of space-time, have already been detected in other areas of the universe, but a merger of such massive black holes would provide an unprecedented opportunity for scientists to study them in more detail. The energy released in such an event would likely be immense, causing a burst of radiation that could impact the surrounding galaxies and possibly even the broader universe. However, despite the cataclysmic forces at play, the chances of individual stars actually colliding are extremely low due to the vast distances between them. While the gravitational effects will certainly disrupt the orbits of stars and planetary systems, the actual collisions between stars are rare. This means that, from a star-to-star perspective, the merger is less likely to directly destroy individual stars. Still, the impact on planetary systems could be more severe, with planets being ejected from their orbits or pushed toward their respective stars. These gravitational shifts may dramatically alter the conditions for life on any planet within the affected areas, making the prospect of human survival in such a scenario uncertain. As the new galaxy emerges from the merger, the resulting structure could be significantly different from the original spirals of both the Milky Way and Andromeda. The combined galaxy may form an elliptical or irregular shape, a far cry from the familiar spiral arms we see today. The stellar population would also be a mix of the two galaxy stars, each with different ages and chemical compositions. The resulting galactic structure may be even larger and more complex than either of the individual galaxies, creating an entirely new cosmic environment for future generations to explore. In the grander scheme of things, the Andromeda-Milky Way collision represents just one chapter in the long and tumultuous history of the universe. Galaxies are in a constant state of motion, drawn together by gravity, only to eventually collide and merge. This process of galactic evolution is ongoing across the cosmos, and the future of our galaxy is tied to the same principles that govern the birth and death of stars, the formation of black holes, and the expansion of space itself. For humanity, the merger of the Milky Way and Andromeda may seem like an event too distant to worry about. However, the understanding of this cosmic process is essential for expanding our knowledge of the universe. By studying these galactic collisions, scientists gain insight into the forces that shape not only galaxies but also the broader structure of the universe. As we continue to observe and explore, the mysteries of the cosmos unfold, bringing us closer to understanding our place in the universe. Ultimately, the merging of the Milky Way and Andromeda is a reminder of the constant change that defines the universe. While it may take billions of years for the two galaxies to collide, the knowledge we gain from this cosmic event will continue to inform our understanding of the universe, long after the collision itself has occurred.